very long title. Simplifying general formula. So that just means they have this general formula here. And it's the general formula, because there's actually lots of general formulas in mathematics. In your functions course, you would have done like general formula for transformations, possibly. This one's specific to distributing binomial terms. So they've given us a term here, and they said, can you simplify it? So at first glance, it looks like they just want me to plug it in, because this is a little simpler to look at than trying to actually write this out in 4 sets of brackets. This becomes very intractable. You look at it and you go, oh man, this is going to be a lot of work, where this other formula is very nice. So we'll start with that. There we go. Get rid of those. We'll briefly review. That becomes our A term. Second part becomes our B term. Our n value is the exponent here. And then our r value is whatever is in here. Now, in this question, they've given us no r value. So we're actually going to have to keep r as just a variable. They haven't told us a term number. But we'll still plug stuff in. So we're going to say, whoops, that's the wrong side of that. T r plus 1 is equal to, we have an n value, so we'll plug it in. We want 4 r. Our a value happens to be an x. Okay. And then it is n, so that's 4 again, minus r. And then our b value is that lovely fraction we talked about earlier. We have 2 over x squared. Okay, I'll put it in brackets just so it separates itself a little. And then r value again, well, we don't know what r is. So this is the general formula. If that's what the question asked for, that's great. But because they've used this word simplifying, we can try to guess at maybe they want us to do some simplification with this second piece here. This piece here is going to be some coefficient, and this is going to be some version of a variable. And because this is an x and this is an x and it's multiplication, there is a possibility we can make this simpler to look at. We can do some kind of simplification of the x values here. This without a number, I mean, there's so many different options there. So we'll rewrite that first part, but we'll see if we can't apply some of our exponent rules to simplify what we have here. So for this one here, this is actually very similar to a rule where we have x a minus b is equivalent to x power of a over x to the power of b. So we can rewrite this as a fraction. So we'll try it out. We'll see if it takes us anywhere. So this would read as x to the power of 4 over x to the power of r. Maybe that'll be helpful. In our second term here, we can distribute the r. Technically, this too is to the power of 1, and this would be known as a power of a power. So this exponential rule is xa to the power of b can be written as xa times b. 1 times r, that one's pretty straightforward. We're just going to go 2 to the power of r. On the bottom, though, that will become x 2r as your exponent. So now when we look at this, take a second glance there. This is multiplication, which means, and I know this looks very similar to this, but this is a combinatorial, so there's no division line, so we don't want to mix that up as we multiply. But we can multiply these two fractions together. So we go t r plus 1 is equal to, we leave the combination as 4 choose r, and then we just multiply numerators by each other and denominators by each other. Both of them end up having variables, so technically there isn't a better order at the moment. But we'll write it as, let's say, 2r x to the power of 4 over, and then this one here, this becomes a good old other rule, x times r, and this is the idea of x a times xb can be written as xa plus b. These bases are the same, so I can actually just add those together. This becomes x r plus 2r. This is the idea of r plus 2r. Well, there's a coefficient in front of this. Technically, it's a 1. We just don't write it in. The variable stays the same, so these are like terms, and we just add our coefficients. So this becomes 3r. So this is to the power of 3r here. Looking at that, I still have this same similar base. So I can go back to this rule I wrote up here. I kind of put it out of the screen. But that's a division part, so I can actually simplify this piece again. This base 2, there's no other base 2, so there's nothing I can really do for simplifying that one. But I still have this base x, and really we could have looked at it here. That's a base x, or maybe I'll highlight it so it's better for the note. That's base x, that's base x, that base x, which means we can apply a whole bunch of exponent laws to bring that into a single base. We'll bring this into a single base. This is x to the power of 4 divided by x to the power of 3r becomes x to the power of 4 minus 3r. I don't know if that's any personally easier to look at. I don't find it wonderful. The fraction might be nicer, but in terms of simplification, they usually think it is a simpler question if it's a single base. So that's what they're trying to get you at. So t r plus 1 is equal to 4 choose r times 2 power of r times x to the power of 4 minus 3r. And that is a simplified, somewhat simplified version of this.